Okay, so in this case, you've got magnesium chloride, MgCl₂, and it's hydrated, and we've been told that its mass is 16.61 grams. We've also been told that the mass of the anhydrous sample of the same magnesium chloride is 9.41 grams, and we need to figure out the value of X, right? So how am I going to do that? Well, one of the first things I'm going to do is I'm going to consider that, well, what I really need to do here is compare the number of moles of the MgCl₂ and the number of moles of H2O. Really, the question is, for every 1 mole of MgCl₂, how many moles of H2O am I going to have, right? And, you know, it's a question of, well, what's the process for answering that question? Well, currently what we've got is masses, right? We've got values of masses. What we really need to make the comparison is values of moles, right? So the equation I'm going to rely on is going to be the number of moles, N is equal to the mass divided by the molar mass, Mr, right? And in this particular case, we're looking at the number of moles of MgCl₂, the number of moles of H2O. So first I'm going to address the MgCl₂. So the number of moles of MgCl₂ is equal to, and so as you can see, it's mass divided by the molar mass, right? So we've got the mass here of the anhydrous of the MgCl₂, so that's going to be 9.41. But what we don't have here is the molar mass. We need to work that out. So so in terms of the molar mass for MgCl₂, we're going to need, of course, Mg and then chlorine, right? So that's going to be so Mr of MgCl₂ is going to be equal to 24.3 plus 2 multiplied by 35.5, okay? And that's going to be 95.3, right? And that's going to be in grams per mole, right? Okay, now, so if we add that here, so 95.3, right? So if you have a go working that out, what you should find is that you're going to get it's equal to 0.098741, right? And that's going to be moles, right? Okay, so we've done the MgCl₂ component. We also need to do the H2O aspect, right? So the moles of the H2O aspect of this. And so for the number of moles of the H2O, right, is equal to what? Well, in order to work this out, we actually need the mass of the H2O, right? I mean, the mass is part of the equation. So if we do a little bit of basic arithmetic here, the H2O mass is simply going to be the difference between the anhydrous sample mass and the hydrated sample mass. So that's effectively 16.61 minus 9.41, right? And that's going to give us our mass for the H2O. So if you do that, that's effectively gonna be 7.2 grams, right? And therefore, so the number of moles for the H2O is going to be 7.2 divided by the molar mass of H2O. Now, in terms of the molar mass, we can use the periodic table for this. So you may already know what the molar mass of H2O is, but you've got hydrogen and you've got oxygen here, right? So it's going to be 1 times 2 plus 16, okay? And that's going to give you, of course, 18, right? And that's going to be in grams per mole. So that's going to be 18 here, right? Okay, so that's going to be 0.4. So that's going to give you 0.4 moles. What we're going to want to do is represent this as, well, let's first take a look at what the equation actually shows. So what we can see is that MgCl₂ is on the left-hand side, H2O is on the right-hand side. So you really, what we're going to do is set up a molar ratio comparison, right? So, so we're going to say the number of moles of MgCl₂ as a ratio compared to the number of moles of H2O, right? So, and if you add the corresponding mole values, so 0.098741 on this side is a ratio with 0.4 on this side, right? What we want to do is get the value on the left-hand side, the MgCl₂ component. Effectively, the question is, for 1 mole of MgCl₂, we're going to have a certain number of moles of H2O, right? So we really want to get the value on this side to be a 1. So a simple way to do that, to divide it by itself. So divide that by 0.098741, right? And of course that's going to give us 1, right? But then on the other side, because we've done this to the left hand side, because it is a ratio, we do need to do that same operation to the right hand side as well. So we have to also divide that by 0.098741, okay? And what we're going to get out of that is 4.0510. Okay, so now what we want to do at this stage is consider that we really need integer values, and so what we're going to do is we're going to round the this value on the right hand side, and so what we're going to say is that 1 is in a ratio where it's approximately 4, right, on the other side. So it's approximately 4. If you round it, it's basically 4, right? So therefore, x, we can say that x is equal to 4. And if x is equal to 4, then simply it's MgCl₂ dot and then 4 H2O. So our value of x is 4, as you can see. So over here we can say that, well, the value of x is going to be 4. Okay, so that's basically that done.